So for this chapter, she's going to really focus on cartography, making labels, doing label annotations, using some of map coordinates, so a graticule within your map, and then with the challenge problem, you'll work with how do you set up the scale and show your maps. So I love this quote from Morgan the Goat, G-O-A-T, Englishman who went up a hill and came down a mountain. Great mapping video or geography video. So she's going to talk about kind of basic geographic framework, those map elements, choosing coordinate system, map scale, map coordinates, and then a lot about creating text and labels, and then just doing a nice layout. We don't always agree on the layout, but actually this layout is very nice. And then there's some great templates within ArcGIS that you can work with. Make sure when you choose, if you choose a template, that you know the size so that when you send it to the printer you can make adjustments for that. So she talks a bit about, planning your map, going over the objective, what are the data layers you need, how do you lay it out, are you planning to do paper, digital? We were talking in class about how the output was dramatically different depending on whether we were showing it as a paper map or online, and then thinking about the colors and the symbol schemes, how much generalization you needed, that kind of stuff. She goes over a text hierarchy. We did this in some of the readings last chapter on quality map making, and this idea of thinking about whether you're doing serif text or sans serif text. The convention used to be that paper or lots of reading you'd used a serif text, which is like the little tabs, and sans serif text was great for titles and things like that, and then sometimes online digital media did better with a sans serif text. So remember that discussion text should never, hardly ever, hardly never be center justified. It's just really difficult to read. So I have a couple examples of kind of a bad map, things that you can talk about when you talk about text hierarchy. It's completely incorrect. The decimal degrees is a really poor choice for scale. Nobody would measure in that. There's underscores in the legend, probably unnecessary elements like the word country. You probably don't need that. It's really not centered. A lot of white space, very poorly balanced, and this is somewhat better. It's not perfect. So Price will show you some ways to use definition queries and clips visual clips that don't actually clip your data, that can help you get a much nicer looking map. A lot of discussion about north arrows, so we can take a look at this blog from Esri. I think the consensus is if you're working for a shop that uses north arrows, you put them on. A lot of people really like them, but they should never be the major focus. They should be somewhat discreet, and may at this point be somewhat unnecessary unless your map is not pointing north or up. In the legend, she talks a lot about what novice cartographers do. Making numbers unreadable was one of the major items. No commas in long numbers, really insignificant decimals being added out in the mantissa really long. Make sure that you've removed the underscores that are part of the file name but don't need to be in the table of contents or in the legend. And just make sure it's really readable. The second aspect for kind of the map elements is scale. You need to kind of think about what you want to show, what size it needs to be, and again, how you show a scale is going to depend on who you're working for. So I always, if I were doing a ratio scale, I would want this to be in even increments, 1 to 500,000, or 50 feet, not 32 feet. However, if I'm working with, let's say, engineering scale, and they want their information in 1 inch equals 32 feet, then everything else has to reflect that. And so how do you set that? If they want me to make a map that's 1 inch equals 115 feet, how do I make that determination so that my data will actually show that? When we talk about coordinate systems and projections, the geographic coordinate system is basically that grid, and it's used because it's easy for collecting data. It's translatable or transmutable. I can share it from one place to the other, and it's kind of a common starting place. The problem with it is if I leave my data in an unprojected coordinate system, I can look at those angular units, and they're in degrees. So that means any type of spatial analysis I do is going to be based on angular degrees, and they become very meaningless. So if you're going to do spatial analysis and measurement, you want to convert your data or project it or reproject it into some kind of data unit that has linear units and not angular units of measurement. So the Mercator, if I open up the data source, it will show me that the data is in meters for this one. I want to talk just a little bit about different ways to project or reproject your data. ArcGIS, ArcMap has the ability to project your data on the fly, which means it's not actually changing your data. To reproject it means that you create a new layer or a new feature, and there's also something called defining a projection, which you hardly ever want to do. ArcMap beautifully projects on the fly. So you can have data in several different coordinate systems. There's a demo that will show that, but the data will line up. The data is not altered. It's all in the same original projection. It's just going to be visualized in whatever projection I choose in my table of contents. It cannot project on the fly if you bring in data that has not been defined. And what that means is that all data was created with some kind of coordinate system or projection, and that information has been lost. And so until you know what that information is, ArcMap cannot align it properly. And it's important to know that the default projection is actually whatever you add first in the table of contents. That will be your default projection. So there's some nice links on one of the older ArcGIS websites that talks about default projections. So I get this a lot. If you look this up, there's a whole bunch of information about, hey, my data won't line up. One of the problems, if a student is bringing in XY coordinate data in a table of index table or CSV, and they say my data is not lining up, usually that's because when you import the data, it asks you what projection, and it will default to the projection that your table of contents is in. And what it's really asking you is, what is the projection that was used when you collected those XY coordinates? So if you're working in state plane but you collected the coordinates in WGS 84, you need to select WGS 84, and then later you can reproject those coordinates. So that will happen often. The other problem is if you have brought in a shape file that doesn't have the projection information with it, or it's defined incorrectly, it will not line up. And it can happen in a feature data set. Now, a feature data set enforces a projection, but if I have corrupted data to begin with and bring it into my feature data set, then that will just perpetuate that corruption. So if you want to reproject data, you can use the reprojection tool. You can export it into a feature data set that has a different projection. The reprojection tool creates a new feature. And why would you use that if you can do on the fly? It's just good standard practices to keep your data in the same projection if you can. So a little bit about defining. You need to know the original projection information or coordinate system information to define it. So you'll get a warning that your data is not projected and cannot be drawn or shown. And so often students say, well, I want to work in WGS 84, so that's what I'm going to set this to be. The problem is you may have corrupted the data. So it's sort of like, let's say I have my house number is 399 and somebody steals the brass numbers off my house. And I text a contractor and I say, could you replace those numbers? It's 933. And he puts 933 up on my house. It's wrong. My mail is not going to be delivered because I have the wrong address, even though my house hasn't moved, right? So you have to give the correct information, and that becomes kind of a game, a guessing game, to find out what that data is. So I have some readings that can help you with that, but one thing you can do is call the person and say, hey, what projection did you use? I don't have the projection file. The other thing you can do is look on the website and see if that's listed. On this website, University of Oregon, they give you transportation information, and when you download these shape files, you get the shape file, the index, and the database. You do not get the projection information, so this data cannot be used unless you define the projection correctly. Now, luckily on the web page, they have information about the projection, and that gives you that. If you don't have that, then you have to start playing games. You have to decide, is it global data? Is it local data? Is it of just Oregon? And then start working through the different definitions until you can get it to line up. And to do that, you want to use some data that you know is correct. And that's one of the great benefits of the streamed image maps. And that's, so I can put on that knowing that's correct, and then try to set the definition at various projections to see if they line up. And once it lines up, then I can feel fairly comfortable that that is the projection type. So everybody this week will make the same map in the tutorial. They should all look just about exactly alike. And then for the exercise this week, you're going to actually do her exercises and the challenge problem and turn those in as PDF maps.